In this second segment on geometrical optics, we're going to take a look at dispersion. So dispersion happens when the index of refraction for material is not constant with respect to frequency. So you consider water. Where for water, the index of refraction at red, a wavelength of 669 nanometers, is 1.331 and ranges all the way to 1.342 at violet. What does this mean, right? What does this mean? Since the index of refraction is the ratio between the speed of light in vacuum and the speed of light in the material, this means that violet moves slower in water than red, right? Since N equals C, N equals C over the actual velocity, speed of light in vacuum over the velocity in the material, the higher this number, the slower the velocity of the actual wave or the actual photon. So in water, violet photons move slower than red photons. This also affects the angle at which they bend, right? This affects the angle as they bend because that index of refraction goes into Snell's law. So for red light, you come in let's say we come in at 45 degrees to the vertical, which is what I've tried to draw, or which is kind of drawn here, right? So it's about 45 degrees. We come in at 45 degrees to the vertical, and then we look internally, right? What happens with respect to this angle? Well, the red light bends to 32.1 degrees and the violet light bends to 31.8 degrees once you put in all the numbers. And this 0.707 is just a sine of 45 degrees. So that might seem like a slight difference, right? Red light is there, violet light goes to there. Seems like a small difference, but as you can see from this diagram, this is what gives us rainbows. If the sun is behind you, it comes in, bounces through a water droplet and comes out, and because of dispersion the colors spread, right? The colors spread. Okay. This also is what gives us sunsets, by the way. Oh, that's my little segment on dispersion. And until next time.